You understand this one or not, first of all? Very simple. Here you need to be observed. This is 1, 0, 1, 0, 1. In the signature point of view, first document we have to choose these four input boolean matrix is there, shingles versus document. So you should understand this is the particular one. Based on that, we need to be write it down. This particular signature matrix 2 1 2 1 means okay, we are unable to decide what is there here. Similarity point of view, here 0 is there, that's why you are unable to decide this one. Then you need to check the 2, right? Once you check the 2, what happens here? Again you need to be observe. Next you may observe here, this is 2. Again here 1 is there, you keep it, but here 1 is there, so you are unable to decide the signature. Because of that, here you need to be keep it the 4. This is 1 0 1 0 1. After that 2 1 0 0 1. So here 1, here okay, there is no problem, but here is the problem. Because of that, okay, you need to be go for a 4. So such a way that you need to be develop, okay, the complete, okay, signature of matrix. After that, in Min-hash property we applied, we understand the similarity. After that, we computed this particular value. This particular value means 1 3. Okay, 1 2 3. You need to be find, okay, this particular signature and column values, which will be okay 0.75, 0.67, and so on. It will be there in this. Like that, okay, we completed last discussion. Now we are entering to discuss about the locality sensitive hashing. In the locality sensitive hashing, the first one is going to be, the first cut is going to be find a document with Jaccard similarity at least S. The similarity threshold, for example, S is going to be equal to 0.8. Means the point is till now what we were discussed one major point, that is we used a Min-hash and we compress the large document into a small signatures, and after we need to be preserve the expected similarity of any pair of documents. It still may be impossible to find the pair with the greatest similarity, which is going to be affect the complete discussion. Are you understand? Min-hashing is there. We will use min-hashing to compress the large document into small signatures. Again, we need to be preserve the expected similarity of any pair of documents, so that you have to be find the greatest similarity between two documents. Okay, that is our main target. The target we are going to be achieved with help of locality sensitive hashing. The locality sensitive hashing general idea is going to be, you need to be observed over here. Here, okay, you need to be observed general idea. Use the function f of xy that tells whether x and y is a candidate pair. How you decide this candidate pair? The candidate pair, how we will decide? A pair of element whose similarity must be evaluated. Understand? The main, okay, LSH is going to be, main idea of LSH is going to be to find the candidate pair. Right? For that, we will use this Min-hash matrix. In the Min-hash matrix, generally we are going to be use the signature matrix M. From this signature matrix M, we are going to be map that signature matrix M to buckets. So, if any two documents are there, that two documents we need to be okay. We need to be used to map to hash with the same bucket. We'll see how we will perform this one. That means here we need to be understand the pick up a similarity of threshold S. The threshold S is going to be from between the 0 to 1. So that once is going to be S is defined, then you have to be find, okay, what is the candidate pair. So column X and column Y of a particular matrix M is there. Candidate pair you need to be okay, calculate if the signature agrees on at least one fraction S of their rows. It means you need to be observed here. Suppose I am finding m of I comma x, which is going to be equal to m of I comma y. So this needs to be happen at least a fraction of s values of this I. So that's why the document x and y to have the same similarity as their signatures. We will see that. The big idea is going to be the hash of columns, signature matrix m several times, arrange that similar columns, and after that you need to be compute the same bucket with the high probability. So candidate pairs are going to be used to map to hash. Suppose here you need to be observe the partition of that matrix m into b bands. Means whatever the matrix is there, the matrix will need to be divided into b bands. Here you need to be observed this is the band 1, band 2, band 3, band 4, and so on. Okay, and this is going to be our complete signature matrix. And each matrix, each column consisting a row per bands, r rows per band. That means r row values are there here. And here, this particular common portion we are going to treat it as our signature. So how many signatures are there? 1, 2, 3, 4, 5 signatures are there in this. Why? Because you have 5 bands, so you are able to calculate the 5 signatures that you need to be understand, right? Anybody required more explanation over here?
No, sir.
Right? Here you have a B bands, and each band required R rows per band, the values. So divide that matrix into B bands of R rows. For each band, hash its portion of each column into hash table with the K buckets. So here K is going to be used for our K as maximum as possible. And we have to be find the candidate of a column pairs. So we need to be use the band, whatever the band is there, that is going to be greater than or equal to 1 of that particular same bucket. So whenever you have a case, suppose B band and R columns are there, out of which you need to be find similar pairs of pairs of documents. So that similar documents you need to consider, and you need to be omit the few non-similar pairs in that. The example here you need to be observed. Suppose here how many in this row? Suppose how many documents are there? 7 documents are there. 1, 2, 3, 4, 5, 6, 7 documents are there. You may observe these 7 documents were going to be mapped to this 4 column signature only. Are you fine? Are you understand what I'm saying? So now we observe here this is the second one is there, second document is there, second document is mapping with the 6th document. Are you clear now? This is the second document which is similar to this 6th document. That's why you observe this document is mapping to a hash value. The 6th document is also going to be mapping to the 6th value. Are you fine? Any doubts over here?
No, sir.
Very simple it is. This is the band 1. So band 0, suppose. This is band 1. This is band 2. This is band 3. And this is going to be band 4. In this case, each band consisting what? A row of documents are there. These row of documents we need to be mapped to this hash function. You can come after 5. Okay, so that means this single hash value is going to be mapped to these 2 documents. Single hash value is going to map to these 2 documents. such a way that so the B bands and R rows are there. These B bands and R rows we are going to be used to develop the column. So now here what we need to be understand based on this hash value, we can treat column 2 and 6 are preferably identical. So you treat these two are going to be a candidate pair. These two are going to be treated as a candidate pair. So now you have to observe here the column 6. This is the 6 and 7. These two documents need to be. This is the 7th document. This is the 6th document. This is 6 and this is 7. These two are different documents. These two are not mapping to a single hash value. If these two are going to be mapped to single hash value, these two we are going to treat as a candidate pair. Fine. Any questions on the candidate pair? Are you understand the candidate pair or not? May I get some yes or no? On our chat box who are online, okay, please okay, share your okay. You understand this candidate pair or not? If you understand, yes. If you not understand, where you are missing to understand, let me know. I want to receive some answers from yourself, your side. Okay, Aryan said once again, take a right. Any other? Only one answer I received. I have not received okay. Other people answers. Other students may answer. Okay, may ask question, or you may say yes or no. Only 4 students answers I received. At least okay, but there are 68 students are there. At least half of the answers I need to receive. Right? Okay. In that case, okay. Again, I will explain. Please try to concentrate on this. So, what is a candidate pair? Just you need to be observed here the candidate pair. In the candidate pair discussion, column X is there and column Y of M are a candidate pair if their signatures agree on at least fraction S of their rows. Means the matrix of I comma X is equal to matrix of I comma Y should be there. So for these two, at least the fraction S value is going to be S, such a way that we need to be find. So it means okay, X and Y have the same Jacob similarity as their signatures. So that the way we are going to be find the similar columns. So if you have a similar columns that are likely to hash to the same bucket, that the probability is also going to be very high. We said here you need to be observed the similar columns and hash that similar columns to the same bucket, right? So now what we were done, we partitioned our matrix into bands, each band consisting some values. Okay, here a row of values are there, right? Understand? So R rows per band is there. R rows per band is there. So that means each one consisting a signature here. We understood this one. Then what we need to do, define, we need to be define the candidate column and pairs. So candidate pair, how we will define? Candidate column pairs are those that has to the same bucket for greater than or equal to band. So in that case, you observe in this particular example, here we have two, column 1 2 and 6. Column 1 2 is this one and column 1 6 is this one. So these two are mapping to this particular hash bucket. Because of that, preferably we are going to be treat this particular means what is the meaning of this one? Jacquard similarity of this particular document, Jacquard similarity of this particular document are almost similar, so that we need to be treated as our candidate pair over here. That's why this particular bucket is mapping to this particular two documents. Okay, we will find some more discussions in the later on discussion. I'm thinking most of you might be understand this one. So we are going to be much more simplify that. You have enough bucket that columns are unlikely to hash to the same bucket unless they are identical in particular band. So we need to be work on same bucket, which means identical in that band. So we will observe that with a small example. Suppose you have a 1 lakh columns of your M. That means you have 100,000 documents. So 100,000 documents required the signature of 100 integers. That means your rows. Therefore, the each signature takes 440 MB information. So you supposed to be choose your B is going to be equal to bands are equal to 20 and R is going to be equal to 5. So finally, we need to be find the pair of documents that at least S is going to be 0.8 similar. So in that case, we need to be assume to take two documents C1, C2, that similarity of C1, C2 is going to be equal to 0.8. Since similarity of C1, C2 is greater than or equal to S, we want S1, S2 to be the candidate pair. So if suppose this is the condition is going to be satisfied, so these should be mapped to a particular common bucket only. That was happened in C2, C6 in the previous example actually. So the probability of C1, C2 identical in one particular band, that is going to be 0.8 to the power 5, that is going to be equal to 0.328. But we are talking about the 80%, the remaining 20% of that 20% are not similar. So that we need to be calculate 1 minus this particular probability, then that would be is going to be equal to 0.00035. So that it means it is going to be 1 by 3000 of the 80% similar column pairs or false negatives. We are not counting them actually. What is the meaning? What is the difference between the false negatives and false positives? We already discussed in the last class. Please recall that one. So finally, we need to be find 99.965% of pairs of truly similar documents with help of this concept. If 30% similarity is there, then you need to be assume C1, C2 is going to be equal to 0.3. Since similarity C1, C2 is going to be less than S, we want to C1, C2 to hash to no common buckets. Means, total the common bucket mapping is going to be depends on your similarity S value. The probability that C1, C2 are identical in one particular band, that's 0.3 to the power 5, that is going to be equal to 0.00243. the probability is identical in at least one of 20 bands, so that the total value is going to be 0.0474. So whenever we observe here, the approximately 4.74 pairs of documents with a similarity 0.3% end up become candidate pairs. So these are called like a false positives. So whenever you have a false positive, you should examine them, but then it will be turned out their similarity is below threshold value. Yes. Such a way that you need to be find okay, what are false positive, false negatives. Based on that, you also need to be define your candidate pair. Any questions more here, please? May I receive some questions from a chat box? Now, all of you understand what is a candidate pair, what is a not candidate pair? Any answer? Yes or no again? Very few answers I received. I need more answers from all the students who are attended today's class. So with help of this one, we try to understand the number of mini hashes we need to be checked. After that, the number of bands we need to be find. Then after the number of rows we need to be checked. Then we need to be balanced false positive and false negatives, so that we will get our LSH value. If we had only 15 bands of 5 rows, the number of false positive would be go down. Put the number of false negatives would be go up. So that's why how to analyze this particular local sensitive hashing. Local sensitive hashing, how we need to be analyzed. Suppose you need to be observed. This portion is going to be definitely fallen less than S. So there is no chance to consider similarity over there. And whenever you come up over here, the probability is going to be definitely more than similarity. So that you need to be considered that are local sensitive values. So finally, you need to be observed if one band of one row, which is going to be like a vertical line, the similarity is going to be equal to similarity of C1, C2 up to sets. The probability of equal hash values, which we are going to be treat as a similarity values. So suppose we have B bands and R rows, the relation is going to be, we need to be defined over here. Column 1, C1, C2 have the similarity T, then pick any band with the R rows, then the probability that all rows in band are equal is going to be T to the power R. In some rows in band unequal, that the probability is going to be 1 minus TR. And no band is not going to be identical, is going to be 1 minus 2 T to the power R whole to the power B. And probability that at least one band identical is going to be 1 minus T to the power R B. So in that case, if you have a B bands or R rows, which gives a formula here, you need to be observed. The similarity is going to be similar to 1 divided by B whole to the power 1 by R. So that we need to be understand here, at least one band is identical, no band is identical, is going to be calculated this like this 1 minus T to the power R whole to the power B, so that it indicates the same row are equal and all rows if a band are equal. Clear? So we have to compute these values, very easily with the help of the similarity of T values. Suppose this example you may observe. Here you observe very carefully. Here these values are going to be going, and there is a lot of differences are there over here. But here immediately it jumps from 4 to 8. So this portion will be observed. 1.86 this portion will be observed. The very big gap is there between these two values. And this particular portion and this particular portion. You will not find much gaps over here. Which indicates that means how false positive and false negatives are going to be created some something to you that we need to measure with help of this one. The green area is going to be false positive rate, and blue area is going to be false negative rate. So we had to consider these two, and we try to find the locality of locality sensitive hashing. We will perform and we will analyze the locality sensitive hashing. So finally, I want to conclude this particular discussion. What we discussed in this particular discussion, where we started and how we won. What is the main mode of this particular chapter? Can you answer? In the chat box, all of you, what is the main mode of this chapter? What we targeted at starting of this chapter? What we targeted? We targeted to know and to measure similarity of items, similarity of documents. We need to be find out. That is our main target. For that, what we discussed, how we need to be find out the similarity of the documents. What mechanism we used? So we have to be supposed to be the hashing. Hashing we will use to find the two documents are going to be similar. Correct. How we need to achieve this particular hashing? We want to develop this hashing with local. What hashing is supposed to be used for to find the micro level similarity between two documents. Locality sensitive hashing. If you want to do locality sensitive hashing, what we supposed to do? Shingling, min hashing, and locality sensitive. Locality sensitive hashing. This is the target of this particular discussion. So how to perform shingling we understand? After shingling, what we develop? Boolean matrix we develop. After Boolean matrix we develop, what we calculated? Min hashing, we use min hashing. With help of min hashing, what we perform? We calculated the signatures. We calculated the signatures. So if suppose I have the end documents, how many what is the size of the signature? Why? Because it will be observed. Okay, we have a Boolean matrix. Boolean matrix is going to be developed based on shinglings by documents. Correct. Shinglings by documents we use to construct Boolean matrix. Correct. So with help of the Boolean matrix, we have to since a large number of documents are there. We created a large number of documents based on that. After that, what we supposed to do? We supposed to do min hashing. In the min hashing, what we supposed to work on? We have to choose the random. That's documents are going to be developed with set of singles. Set of singles are going to be used to construct the Boolean matrix. The Boolean matrix is going to be used to construct the min hash signatures. But from signatures, we need to find it. The signatures are going to be there, but signatures are helpful to you to understand about group these documents, similar documents. So you need to go more precise or more similarity you need. Because of that, we use locality sensitive hashing. Fine. So this is the main mode of this particular chapter. So now I am asking any doubts are there on this particular chapter. And after that, there are several applications are there in this particular locality sensitivity. Several applications and several mechanisms are there. Several functionalities are there. That function all depends on the distance. What are the distances we discussed in the last class? Can you tell me few of you? we discussed Euclidean distance. Next, Manhattan. Then Hamming distance, edit distance, Jacquard distance, cosine distance, etc. We discussed. And locality sensitive, locality sensitive hashing. What is the main mode of the locality sensitive hashing? We should find more nearby such. So they what we will find false positives, false negatives are there. In min hashing, we are not counted false positives and false negatives. But we have to take that into account with help of the candidate pair. The candidate pair, how we are going to be compute? The candidate pair we are going to be compute. Suppose here you need to check. Here you need to check. So here, each document again you need to keep it in the row. Right? And calculate the similarity matrix. The similarity matrix, how we are calculating? There are two documents are there. You are calculating the similarity value. The similarity value we decide as the 0.08 similarity. So that you need to know your B value and R value. Based on that, you need to find your similarity value. So the similarity value less than or equal to 0.8, which means these two are not common. These two are not common bucket. Okay? These two are not mapping to a single hash bucket. Suppose in the previous example here you need to be observe the similarity between these two documents is 0.8, which means this is going to be greater than or equal to your S value. So that this will be we are going to consider as a candidate pair. Clear. That means the total locality sensitive hashing depends on this particular similarity value. Fine. So this is what about we discussed in this particular chapter. Any further questions? Please let me know. Gautam, are you understand? Still you are not understand the discussion of the candidate pair. If you understand the candidate pair, you will be able to understand the locality hashing. Why? Because locality hashing depends on the candidate pairs only. Thank you. So this is what we are about third chapter. Now we have to move forward to discuss about another kind of topic that is going to be our that is going to be the stream of data. Stream data. Now we are not talking about stream data. We are talking about the data which is similarity or not only. But now stream of data. That means we completed high dimensional data. We discussed locality sensitive hashing. There is a clustering document and dimensionality reduction. We completed these discussions. Right? Now we are coming to discuss about infinite data. We completed graph data, similarity ranking. So these are all main applications of our locality sensitive hashing. There are so many locality sensitive hashing concepts are there. So now we are going to target to understand infinite data, filtering the data streams, filtering the query streams, filtering the web address. These are the discussions we are going to be discussing. What is the data stream first of all? So in many data mining discussions, definitely we are not able to find, we are not able to keep entire data set in advance. Example I would like to give you zero day attacks are there in a networking. Zero day attacks means what? There is no data available to the zero day attacks. How can you prevent from that? Fine. So that's why what we need to know, stream management we need to be understand. So the input rate is not with you. The input rate is with the external members only. External sources only. For example, Google queries are there. Twitter or Facebook status updates are there. These are not at your side. Suppose on your Twitter or on your Facebook, how many updates are there? How do you find? So there's no data for you. What input is coming, what update is coming. You don't know that actually. Even WhatsApp also, you don't know what updates are going to come to you today. Any questions? We can think of the data as infinite and non-stationary. And this particular values are going to be changed by the time. Every day you are request. Simply, I would like to say to you, suppose you will be observed from the morning to evening, you are browsing information. Your browsing pattern is similar most of the time. Am I correct? But sometimes it will be random also. Most of the time, it should be similar, but some of the time it's going to be random. How to analyze that without a value? So that input elements enter a rapid rate at one or more input ports are there. The streaming of elements are going to be there. That we are treating as a stream tuple. And after that, we cannot store entire stream accessibility. Instead of that, we have to find how much memory is there, how much stream, how much limited amount of memory we will use to store this particular information. For example, take your web browser. For example, take your web browser. The web browser is going to store all the information. Today, suppose you visited 10 company, 10 websites. All these 10 websites are going to be updated on the Chrome. Only one is updated on the Chrome. So you observe, okay, this is the main. So the optimal utilization of the memory is one requirement for all of us. That's why we should understand SGD is a streaming algorithm. SGD means stochastic gradient descent. Okay. So we can call this as machine learning, and machine learning is going to use online learning, which allows modeling of problems where they have a continuous stream of data, and algorithms are learning it and slowly adapt the changes in the data. Just a minute. I'm coming back. Clear. Okay, so that here you can understand stochastic gradient is used after that. This SVM, SGD SVM cluster makes all small updates. First, try the cluster of training data. Then, for every example from the stream, we slightly update the model such a way that okay, we are going to use this small learning rate and we will let you this one. The general stream processing model is going to be this one. Here, you observe these are going to be. Here you observe this is the input information. So each string consisting some tuples of information. This tuple of information is going to be sent to the processor. This processor uses a standard queries. That standard queries are going to be used to process this processor, as well as sometimes it is some ad hoc queries. After this processing, before this processing, it requires a limited working storage information to store some of the new data, or some data is already in archival. So that archival data, both the archival and limited working storage are going to be used to process this processor to analyze. After this analyzing, it will be released out. Fine. Any questions here? How many of you understand this one? Please let me know. Can you say yes or no if you understand? Streaming of data is there. That streaming of data, just example I would like to give you. Streaming of data means what? Your browsing history is there. The browsing history is a streaming of data. If a request and responses, right? Fine. So that the main point here we try to understand the streaming of data. The streaming of data means you don't have a suppose example I would like to give you an example to understand that is you requested a Google search engine. You requested for a Google search engine. Google search engine is going to be connected to your system. The same ID every day or different ID with a different ID. We don't know that actually. Whether sometimes it might be similar, sometimes it might be different IP addresses. But you don't have control of this IP address on your side. This IP address is not going to be assigned. Who will control this input rate? The input rate is going to control the external numbers only. The Google queries or Twitter, Facebook status. Suppose you have a Twitter account, or a Facebook account, your updates. Update in the sense that whatever the posts are coming to you, that is in your control or in somebody's control. Can you answer for this one? All of you, if you have a Facebook, you are receiving some information from your friends or some other people, that is in your control or not in your control? Please answer for me. Yeah, not in our control. I need an answer from most of you. In your Twitter account, you are receiving some posts that are in your control. So mostly that are not in our control. But how you are going to analyze? So okay, forget about that. Again, another example I would like to say. Today you got some kind of information from the Twitter. The same information are you going to expect from tomorrow? Are you understand my question? Today, you receive some post, XYZ post. Are you going to expect the same kind of post tomorrow also? We can't say anything actually, whether we may receive, may not receive. That is not our control. Why? Because that is not our control. The streaming of data is produced by some external members. So external people. If external people are there, how your data mining mechanism is going to be learned that? Because there is no data with your model. If there is no data, how it is going to be understand that, to learn? Because of that is called a streaming of data. Data streams means that. So here data as infinite and it is non-stationary. And it is going to change over the time. So and these elements are going to be received rapidly and the elements of the stream tuples are not in your control. That's why what we supposed to be understand, we supposed to be understand how to learn that particular streaming of data. So one of the major mechanism is there that is called stochastic gradient descent mechanism, that is a stream algorithm. So the machine learning is going to be allow online learning so that the model is going to be continuously learn the stream of data at a rate of at a small rates. Okay, small rates. So that's why you can call it as a instead of going for a larger update, you need to go slow updates to the model. That's why you require to use a slow or small learning rate. Small learning rate. So then after what we are coming, you have several inputs. You have several inputs. As a stream is going to be entered into your processor. The processor is going to receive the data. To process that received information, it needs to maintain some standard queries. Like select this, that, we have statements like that. Standard queries are required in the processor. With the help of the standard queries and with the help of limited working storage and archival storage. Means limited working storage is your cache memory, archival storage means your memory, suppose you may think. With the help of these two information, you are going to process and produce an output. Okay, done. This is what the general streaming processing model. The problems are going to be too many type of queries one want to answer on data streams, sampling data from the stream, or query overriding windows is another type of queries wants to answer on the data stream, filtering the data stream, counting distinct elements, estimating movements, finding frequent elements. The applications are going to be mining query systems, mining click streams, mining social network, news, feed, etc. Sensor networking, telephone records, IP network monitoring, data speech. So this is we will start. We will try to understand the next class also. We will do the same about this infinite data, which we can treat as a streaming of data. That streaming of data we will try to again discuss in the next class. So please try to ask any questions right now if you have. Any questions? Can you ask now? Data streams? Any questions? If you don't have any questions, please say no. So again, we will meet on Friday. We will finish our lab experiments and whatever class missing yesterday, that class also we will cover. Half an hour class or 40 minutes class we take, and after that we will discuss on the lab program, second lab program. है? I will upload by tomorrow. That's the second program. We try to finish it. That is sufficient for me. And all of you ready for your midterm examination. When is the midterm examinations? Aryan? 18th onwards, no? This week, 18th to 22nd.
सर 15 मेरे को पता था
15th onwards.
yes sir
Okay, 15th onwards, your exams are going to be start and it will be ended by the next week classes probably we will finish this stochastic gradient mechanism, that is streaming data part 1, and after that syllabus is there for you for your examination. I already uploaded chapter 3. How many of you seen that?
yes sir, slides
Slides are updated. And what I'm thinking, can I give one assignment to you before this exam?
Yes, sir.
One particular assignment I'm trying to prepare, and you work on this particular assignment and prepare well for your examination and start your preparation now onwards. It's a easy subject, not a tough subject, right? But vocabulary you should be understand, that's all. Okay? What is no for what? Shall I give assignment or not?
डेडलाइन बाद की रख दीजिएगा मिड टर्म की.
I will keep it okay after midterm only. 20th like that I will keep it. Huh? Or okay, after your that means this week I supposed to be give. Okay. 22nd or 23rd I will give. Okay. Or can I keep it on 25th?
सर ये सर होली है ना तो सर.
Okay, sorry, 25th is a holy. Okay, we'll keep it okay up to 22nd. So holy will be
Sir, 22nd तक पेपर है सर.
So then April 1st.
Yes,
Okay,
sir.
sir.
Okay. So that okay, you will also get to know what kind of questions may come up in the examination. How to prepare for that, huh? Like that, huh? Right. Thank you. We'll meet on Friday.